All right, we're back. This is Techmath1. We're doing the first review on chapter 1-2, and we're on the bottom of page 2 of the review. And so these are the applied problems. And so really, this is just set up and solve. And so as soon as you get them set up, the solving part isn't that tough. It's the setup part. So make sure you take really good notes. It's open note test, so you can use your notes. Velocity, v, acceleration a, and distance s are related by this formula. V squared equals 2as. And now it's going to give you two of the three variables. This is just a formula with three variables. 1, 2, 3 variables. They're going to give you two of the three and then ask you to find the missing one. So find the acceleration. So they didn't give us a. When velocity is 8 and distance is 16. So velocity is 8, so we replace the v with an 8, and we replace the s with a 16. So remember, 8 times 8 is 64, 2 times 16 is 32a, and now look, after that, like just forget about all of that, and look at that equation, easy peasy lemon squeezy. Divide both sides by 32. And we're looking at 2 is equal to a. Now, for my purposes, in this course, I'm not going to really bust your chops about not putting the correct label on it. In other courses, units and labels are very, very important. One that comes to mind, nursing. Definitely, they worry about labels. That you lose the full credit. You have all the math right, but you put the label on wrong. Physics, they worry about labels, you know. So there's a lot of different avenues that you cover where we're very worried about labels. I will not take off points if you forget to label. So this was in meters per second squared, because it's acceleration. And so on the homework, you'll notice they already have the label on it, and on the test, I'll already have the label on it, and so you just have to provide me the correct number. All right, let's look at 31. The perimeter. So perimeter is equal to 2L plus 2W, and then as you read on, they give you the perimeter is 120, and the width is 24. Find the length. All right, so now it looks just like our problems that we just got done working out. Subtract 48 from both sides. And let's see, I did that already, right? For 31, that's 72. And then divide by 2. 36, and that's in centimeters, I think. All right, so both of those were just kind of plug and chug. They gave us a formula, and then we had to just substitute in the values and chug out the answer. Plug and chug. So now 32 gets a little more involved. I'm going to draw a pretty picture. So we have a board, and let's read this problem. We know the board is 96 inches long. We've got a total length of 96 inches. All right, now read carefully. Read and reread. It's to be cut into 3 parts so that the second part equals the first part, and the third part is 24 inches longer than the first part. Okay, so look, just kind of eyeball it, try to make, so those 2 parts are exactly the same. That's X, that's X. That's the first part, that's the second part, this is the third part. The third part, they indicated it was 24 inches longer than the first, or they could have said the second because those are the same. So whatever that is, plus 24. Now, we have to think. There isn't a formula given here. We have to figure this out. Well, if I'm cutting this from this board that's 96, this plus that, I mean, minus the cut. I don't know how much precision. It's 96 inches, so I'm assuming they're not worried about an 1/8 of an inch or a 1/16 of an inch cut. But what's that going to look like is this, 96. So now you have to put on your thinking cap. So now forget about all of the writing and the words, and let's solve this equation. So we got 1x plus 1x plus 1x. Remember, there's a 1 there when there's nothing there. So that's 3x plus 24 is equal to 96. And then we subtract 24 from both sides. 3x is equal to 72. And then I divide both sides by 3. And so now x, we found the first two lengths, right? We divide that and get 24. So that's 24 inches. That means the second part, that's the first part, is x. The second part is also x, 24 inches. And then the third part is whatever that is, plus 24, right? So it's 24 plus 24 is 48 inches. So those are my 3 parts, 24, 24, and 48. Those are the 3 lengths that we're looking for. All right, let's look at the last page, 33, 34, and 35. So 33 is a distance problem where we've got, let's see here, 33 is a train traveled from city A to city B in 4.5 hours at 72 miles per hour. The return trip was made in 4 hours. Find the speed of the return trip. So we've got city A going to city B, and we know distance equals rate times time. So dirt, distance equals rate times time. So first, we're going to have to find the distance between these 2 cities. So find the distance, and that's easy enough, right? So we're going to substitute into that formula. They gave us both the pieces we need. The rate is 72, and the time is 4.5. And so the total distance between those 2 cities is 324 miles. All right. So we've got that, but they didn't say how far is it. They said, how fast did you go back if the time you made was 4 hours? So we want to go back, and this time we're going to use the same formula, but this time we have the distance that we figured out, and we don't have the rate, and we do have the time. And so the formula looks like that. 324 equals 4r, that's our equation. Divide by 4, and r is equal to 81 miles per hour, which does make sense. It would have to be faster than 72, because at 72 miles it took 4.5 hours. So at 81, it'll only take 4 hours. So we should have known going into that problem that the speed was going to be faster than 72. I didn't know how much faster, but we knew it was going to be faster. All right, so now let's look at 34 and 35 are very similar problems to that one, where 34 looks like this. We've got 2 people going at different speeds in 2 different directions, in opposite directions. So they start traveling away from one another. So one is going 55 miles per hour, and the other is going in the exact opposite direction at 45 miles per hour. And they want to know how long will it be before they're 150 miles apart. So how long before they're 150 miles apart? Here, I can read the actual problem. I have the paper. It says a bus and a truck leave the same terminal at noon, traveling in opposite directions. The bus travels 55 miles per hour and the truck travels 45 miles per hour. And how many hours will they be 150 miles apart? Okay, so the whole at noon didn't matter because they didn't ask what time are they 50 miles apart. They just said how many hours. So the noon was garbage information. We didn't need to know when they left. So think about this. It's distance equals rate times time, but in this case, like in an hour, they would be 100 miles away from each other, because each hour, this one's getting 55 miles farther and this one's getting 45 miles farther. So what we can do with those rates when they're going in opposite directions like that is add them up. So basically, they're covering 100, they're going 100 miles per hour combined away from one another. So after 1 hour, they would be 100 miles away. After 2 hours, they would be 200 miles away. 110 that way and 90 that way. We could even pinpoint, who did what. We don't want to do a time graph where we do that. We want to take this as the rate, and we don't know the time, but they did give us a distance. They wanted 150, and then we just solve. So that's a super easy one to solve. 1.5 is equal to t. So the time is 1.5 hours, 1.5 hours. And then they'll be 150 miles apart. And then 35 is very similar to that. One car leaves traveling 42 miles per hour. A second car leaves the same motel an hour later going 56 miles per hour. How long does it take the second car to catch the first one? So one car leaves at 42. So this one is going to be distance is equal to 42 miles per hour times time plus 1, because he's got an hour jump on the other person. The other person that's going 52 miles, or 55 miles, or 56 miles, 56 miles, that's 56 times just t. So basically, this speed is 42 times t plus 1, because he's got an hour advantage, if you will, in his distance, where this one left just right now at 56 times t. Now we want to just know when those distances will be the same. So the setup of that one is maybe a little harder than 34, where how will I figure out the time? Well, it's when those distances are the same. It's when he catches that one. So it is going to be 42 times t plus 1 equals 56t. So now forget about all of the words and all of the pictures and everything, and just solve this equation. These are just like what we did before. 42t plus 42 equals 56t. Let's get all the t's over to one side. 14t divided by 14. And t is equal to 3. So in 3 hours' time, this car going 56 miles per hour will catch up with the one going an average of 42 miles per hour. All right, so that's the review. The test is going to look very, very similar to the review. Study, study, study. Make sure you're familiar with the material. Good luck.